Bismillahirrahmanirrahim. Let's go over a small topic before going into details of the lag compensated design. That small topic is integrating networks. Integrating networks. What are the integrating networks? It's a combination of a proportional controller, uh, P, and integral. Proportional and integral controllers, basically PI controller. And we know that the PI controller, the transfer function of controller GC, it's a K proportional plus Ki over S. And if we simplify it, we already did this in the chapter 7, and KPS plus Ki over S. So this uh, integrating network is a combination of a pole at origin and a zero at a finite location, a real zero at finite location. And what's the value of this real zero? Just put it in the standard form. So it is just keep kp outside. So s plus ki over kp over s. So the zero is located at minus ki over kp, minus ki over kp. That's the location of zero. And where we use the integrating network, suppose if a system is of type 1 and we want to make the steady state error 0 against a ramp input, so we need to uh, add an integrator in the loop to improve the type of system. Suppose we want the error to be a small number against the ramp input, not exactly 0, uh, and this system is already type 1 system, so error will be finite. One way to reduce that error is to increase the velocity error constant, and you know the velocity error constant, suppose the loop transfer function. The system is given like k over s s plus 2, so it will have velocity error constant because error will be finite against ramp input. This is gp, suppose this is plot gps, this is plot, and the velocity kv will be, you'll multiply and you'll have this plot s s plus 2, and you'll multiply with s, and limit s approaches to 0, so kv is k over 2 for this case, and ess against ramp, it will be 1 over kv, which is 2 over k. So in order to reduce the velocity error constant, in order to reduce the steady state error, you need to increase the k, which will improve the velocity error constant. And you need to, if we want to have a very small error, suppose 5%, then k will be a huge number, because 2 over k will be equal to 0.05, and k will be 2 over 0.05, which is at least 40. So having a large value of k, what will happen? You know that the transient response will start looking bad. So what is the other way to reduce the velocity error constant is to add a PI controller or a integrating network in the system such that the velocity and the error against the ramp velocity is reduced to zero. Mean you will improve the type of system by adding this pole at origin in the loop transfer function. By the way, integrating network is like this. If I place it on the uh, complex plane, a pole at origin and a finite zero minus k I over k p